it is important to remember that absolute value represents distance. Technically distance on a number line, but I'm going to leave it at distance. Nah, I won't. Distance on a number line. For example, if I gave you a number line, like the one on this post-it note that's not there yet, and I said we have 0, -1, -2, -3, 1, 2, 3, and I said the absolute value of x is equal to 3. What that means is I could travel from 0 to 3. I could travel from 0 to -3. I've still traveled a complete distance of 3. I might have moved forward, I might have moved backward, but I moved, right? So it represents distance on a number line, which really means that you make it positive. If it's not positive, you make it positive. If it is positive, you keep it positive. If it's 0, well, it's 0. You can't do anything with it, right? Okay, so if the absolute value of something gave me 7, then I have two options. I could have said, well, I was taking the absolute value of 7 and I got 7. I could have said I was taking the absolute value of -7 and I got, well, 7. So I really have two answers. One of them is 7. The other one is -7, and that is the big idea behind this whole lesson. You're going to have, and I'm halfway lying to you here, but you're going to have two answers. There will be exceptions to that in a few minutes, but for now, you're going to have two answers. You're going to have the positive and you're going to have the negative. And it gets a little more complicated than that, but that's it. So absolute value of 3 times x gave me 12, which means 3 times x could have equaled 12. And I was good with that, and I didn't have to make it positive. But 3 times x could have given me -12, and I had to make it positive. So either one of those is valid, and we divide both of them by 3, and we get 4 over here, and we get -4 over here. So we have two answers. So when I look at this one, I have two answers. Here I have two answers. And this one I'm going to have guess. Yep, you're right, two answers. And those two answers are not going to be 7 and -7, but that idea will lead us to that. So all this stuff right here, x plus 2, I took the absolute value of it, meaning I said, you know what, let's make it positive, and I got 7. But I took this stuff, and maybe it was +7, maybe it was -7, and I had to make it positive. So I hope you realize the steps, which we're going to write down in a few minutes, but I've just dropped the bars and done, it sounds like I'm rapping, right? I'm dropping the bars, and I am going to make this number positive and negative, and then I'll just solve them both. So if I subtract 2 on this side, I'll have 5. If I subtract 2 over here on both of these sides, I'll have -9. So I do want to warn you that not every time are you going to have like 7 and -7, 4 and -4. This you have 5 and -9. Actually, they're not always both opposite signs either. Okay, so let's do this next one. And I want to warn you about this one because it's set up differently. It looks like kind of like the same idea as this, but it's different. And here's how it's different. I need to get the bars all alone on one side. Now, not every absolute value equation is going to be structured that way, but in this case it is. I'm going to subtract 2 before I ever start because that 2 was not even inside those absolute value bars. And so now I have this. Now, you probably already know the answers, plural, but let's walk through it. When I took the absolute value of something, I got 5. So maybe it was 5. Maybe it was -5 and I had to make it positive. Either way, I have two answers, and there's nothing really to solve on this one. Okay? So I'm going to go ahead and flip the paper over and write this. Now, you flip your paper over, but I actually have 2 pages. So what is or are the first steps in solving an absolute value equation? I think step 1, I want to bring it over here, you should get the bars, the absolute value bars, alone on one side of the equation. And then step 2, is going to be to look at this equation you have, this thing you have. Try to say two words at one time. And you're going to say, well, maybe it was 7, maybe it was negative 7, maybe it was 12, maybe it was negative 12. And you set up two equations. So I'm going to go back and add a couple words to this in a few minutes, but set up two equations. And they're going to look like this. You're going to have the stuff that was in your bars equal to a positive, and then the stuff that was in your bars equal to a negative. Okay? So I'm going to say there's an expression here that came out of the bars, and there's an expression here that came out of the bars. Don't need the bars anymore, because we're dealing with that by making it plus and minus, positive, negative. Now, I'm going to add some words to that in a minute. Okay? But let's go back to the front side. Back to the front. That makes sense. Okay, so if we have this, well, we get the bars alone. Oh, they already are. Lucky us. So we already have like bars equals something. So now I'm going to drop the bars. And I'm going to drop my mixtape too. And we're going to say, well, 4x plus 2 equals 14. Well, that's great. I got that. It equals the positive. I also need that it equals the negative. So we're going to say 4x plus 2 equals negative 14. Maybe it was 14, maybe it was negative 14, but we had to make it positive 14, right? So we subtract 2 from both sides, and we're going to have 12 right here. So 4x equals 12. We divide by 4 and we get 3. We're going to subtract 2 from both sides here. We cancel those. 4x equals, oops, negative 16. I was looking at that as a positive 14. It's like, man, I just did this equation. Sorry. Negative 16. So we'll divide both sides by 4, and we get negative 4. So we have two answers. One of them is 3. The other one is negative 4. And I'm going to do something on this one I haven't done on the other ones, and you don't have to write it unless you really want to. I'm going to cram it into a Post-it note. Wasting Post-it notes on this lesson. But what I'm going to do is check my answers and make sure they work. And that's a good idea, just to make sure you're on the right track, and it might come in handy on some other types of problems later. Hint, hint. So 4 times 3 plus 2, and we're going to take the absolute value of that. And if I get 14, then I'm happy, right? So this is 12 plus 2, and that's absolute value of 14. Absolute value of 14 is, well, 14. All right, cool. Let's check this one. 4 times negative 4 plus 2, take the absolute value of that. That's negative 16 plus 2. Well, negative 16 plus 2 is negative 14. And the absolute value of negative 14 is, well, it's 14. Ah, it does work. Great. That's going to come in handy on some other problems in just a few minutes. In the meantime, let's move on. So, I'd get the bars alone. They're alone. And I set it equal to 0 and to negative 0. Wait a minute. You can't have negative 0. Negative 0 is not a thing. And positive 0 is not a thing. 0 is 0. It's not positive or negative. So this little step right here needs a little bit of extra stuff. So I'm going to set up two equations. I'll do that if, whoops, wrong color. That's blue. Oh well, we'll switch. If the absolute value with the expression inside, equaled a positive to start with. Okay, so this looks a little wordy, and that blue's throwing you off. But if originally, once we solved, we had bars equals positive, we do this. If it was bars equals 0, we can't do positive and negative. All right, so let's just do what we can, right? So 4x minus 6 equals 0. Well, we'll add 6 to both sides. Cancel those. 4x equals 6, and we'll divide by 4. And so x equals, well, 6 over 4. You can't divide it. You type it in your calculator, you get 1.5. Do that if you want to. I'm going to call it 3 halves. That reduces. And that's it. And that's all I can do. So I said all these have two answers, and that was a lie. Because sometimes they just have one. Right? That's it. That's all you can do with it. So then, from here on out, it's going to be just kind of like basic practice of what we've been doing. So I'm going to kind of shift gears a little bit here, and I'm going to show you, I'm going to do the next two by hand, but I'm also going to show you the next two on the computer and show you just kind of a cool way of checking your answer or doing it that way. I've shown you this way because I want us to understand the concepts of what absolute value is. I hate for us to jump to a graph and be like, look, this is a shortcut. I don't want to show you a shortcut without showing you that absolute value is distance on a number line, and you have to make it positive, and maybe it was negative to start with inside those bars. So let's start with this. Let's solve for the bars. I had to do that on this one, just like I had to do it on this one. So let's solve for the bars. We're going to add 3 to both sides. So plus 3, cancel, cancel. And we're going to have bars equals 9. Okay, let's go to our steps for a second. Flip your paper over if you want to. I'm going to grab my other paper. Get the bars alone on one side, and then set up two equations. It's positive, it's negative if it was equal to a positive to start with, and it is. It's equal to 9, so we're good to go. It wasn't 0, it wasn't negative, which we haven't encountered yet. So 2x plus 1 equals 9. 2x plus 1 equals negative 9, and we'll solve them both. We'll do this quickly. We subtract 1 from both sides, and that gives me 8 right here. And, sorry, got tangled in the cord for a second there. X equals 4. And then we'll subtract 1, so 2x equals negative 10. And we have negative 5. We could check both of those if we wanted to. I choose not to, though. Okay? All right, this next one, and we'll graph it in a minute. But this next one, the bars are not alone. Let's divide by 2. And when I do, I have absolute value of x minus 1 equals, well, just 4. Just 4. Okay? And it's equal to a positive, so we're good. We're going to drop the bars, make it positive. Well, it was positive. We're going to drop the bars, make it negative, and we'll add 1 to this side. We'll add 1 to this side, and we have our two answers. Okay, let's shift gears here for just a second. I'm going to leave my paperweight right there, and we are going to go to Desmos, and we're going to find sort of a shortcut-ish. There's more than one way of doing this, but let's go to Desmos and we'll do it. Okay, here goes. What I'm going to do is type the original function, the original equation, it's not a function, into Desmos. So I'm going to type the bars, and in case you need to know, the bars are right there. It's above the enter key, shift, and then the button above the enter key, and then 2x plus 1 minus 3, and that equals 6. And when I do that, I see these two vertical lines. And these two vertical lines represent the x values that could work. See, absolute value is distance on a number line, and it's representing like x is the number line, the x-axis is the number line. So one of my answers is here at 4. And I click on it all I want, but it won't show up the answer, but I can count over there, right? So the answer is 4, and the other answer is negative 5. And where am I there? And I knew that. 4 and negative 5. Now, what if it's a fraction that's kind of hard to see? We'll get there in a minute. So I can do the same thing with another one. So I can do 2 times the absolute value, x minus 1. I'm doing the very last problem on the front. And I have negative 3 and 5. And we can count and find them. Sometimes they're harder to see. But in this case, it's pretty easy. And it's negative 3 and 5 in no particular order. Here we have 5 and negative 3. They don't have to be in that specific order. Okay. I'm going to do a different method really quickly. So what I just showed you works great. But again, what if this wasn't 5? What if it was 5.379826491 and you really couldn't tell? And you thought it was 5, but your teacher counts it wrong because you really couldn't tell because it was just the screen resolution is only so good, right? You know. So what if it was a situation like that? Well, I'm glad you asked. Let's do that exact same problem, but we're going to do it a different way. So here's the deal. Here's the way I'm going to do it. I'm going to type in Desmos, original problem, before I divide, before I do anything. I'm going to type this side as a function, and I'm going to type this side as a function. Here's the original. So 2 absolute value x minus 1, and then the other side said 8. So y equals this, and y equals that. And I'm going to find where they meet. Now, I'm going to find the x values where they meet. That's what I'm looking for. So y equals 2 x minus 1. And then y equals 8. And I don't see anything yet, but if I scroll around a little bit and zoom in and out, I'll see it. Let me change some colors here. I'm going to change them to red and blue. There we go. And now it's a little more obvious. They meet here. And they meet here. Now, that's a lot of information, negative 3 comma 8 and 5 comma 8, and that's great and that's fantastic, but they didn't ask for that. They said solve, which means tell me what x is. There's no y in this, so I just need the x values, which is negative 3 and positive 5. That's all I need, right? Okay, let's move over to the back side. We're going to do the next one on Desmos. So what I'm going to type, and I'll write it on the actual paper, is y equals absolute value of negative x plus 5 and then plus 2. I'm not solving, not doing anything, and I know you're like, but what about your steps? What about get the bars on? Cool, do it, great, fine. And I love to do that, and it saves you time if they're pretty straightforward and they're pretty easy, like that or that. But sometimes with ones like this, it's not painful, but you could probably type it in just as fast. It just depends on your method here. Okay, so when I do this, I'm going to find maybe 2 points where they intersect. I'll go ahead and say there are definitely 2 points where they intersect. And I'm looking for the x values because that's, well, what they told me to solve for. So final answer is going to be x equals something and x equals something. And we'll find out what they are. So here goes. Y equals absolute value of, oh, we got a mess here, don't we? Okay. Negative x plus 5 and then plus 2. And then the other one is y equals, whoops, y equals 7. And we want to find out where they meet. Well, they meet here, and they meet here. And now here and here are two different coordinates, but all I need is the x value. So 0 and 10. So 0, 10, done. Okay, let's do the next one. That was my maniacal laugh because I know what's happening on this one. Something crazy is about to happen. Let's graph it, see what happens. Okay, so y equals the left, y equals the right, find out where they intersect. I'm not good at my maniacal laugh, am I? I'd be a terrible evil scientist. Maybe I'd be a better evil mathematician. Okay, I'm looking for where they meet, and they don't meet. Okay, so I have this absolute value function up here, I have this horizontal line down here, and they never touch. So the answer is no solution. Okay? And you're probably wondering why. Well, I'm glad you're wondering, because I'm going to tell you. That is my answer. My answer is I have no answer. But the reason I have no answer, I'm going to do it the way we did on the front side of the paper, when I said, hey, let's get the bars alone. So here are my steps. Get the bars alone on one side of the equation. Let's do it. So I'm going to bring it over here, and I'm going to just start by solving. Let's subtract 3 from both sides. Cancel those. Absolute value of x minus 2 equals negative 2. And then, step 2 of my direction said, set up two equations only if the expression is equal to a positive. Well, it's equal to a negative. It's not even equal to a 0. And so here's the deal. Let's go back to the definition of absolute value. Absolute value represents distance. No one ever looked at you and said, I ran negative 2 miles today. That doesn't even make sense. Even if they ran backwards, they ran 2 miles. They didn't run negative 2 miles. So absolute value cannot equal a negative. Now, you might, in the process of solving, get negative answers, and that's okay. But when I'm looking at just the bars, absolute value equals, it doesn't equal a negative. This is wrong. This can't happen. That is incorrect. No, there's no solution. It won't happen. And graphing it told me that. So let's slide down to the bottom of the paper. And if it equals a positive number, then we have two solutions. We did one like this. If it equals 0, well, you can't do positive and negative, so you have one solution. And if it equals a negative number, you have 0 solutions. And the next two aren't in any of those categories. It's not equal to a number. It's equal to an expression that has a variable in it, and so Desmos comes in very handy in these cases. So we're going to graph this one, and we're going to graph this one, and then we'll be done. So here goes. I just wrote on my thumb. Oh well. Y equals absolute value of x plus 2, and then y equals absolute, whoa, not absolute value, my bad. Got in such a habit of doing absolute value. That was tragic, wasn't it? 3x minus 8, and we'll type those in. We'll see where they cross. If they cross. Sometimes they don't. So x plus 2, and then y equals 3x minus 8. And I want to see where they cross, and they cross here at 5, 7. Okay, now I'm not going to put the coordinate 5, 7. I'm going to put 5. Now, I'm not going to put just 5. I need to know x equals. So don't just put 5 on your paper and go home. X equals 5. That's it. Okay, let me show you something cool though. Kind of look at the way these things are pointed and structured. And no matter how much you zoom in or out, you'll only see that one point of intersection. Now you do see x-intercept, y-intercept, because it just shows you the cool parts of the graph. Nice, neat features, but it doesn't ever show you any more than one point of intersection, because that's all it has. So sometimes you might have to scroll around to see another point of intersection. So let's do the next one. And when I do the next one, it's going to say y equals absolute value of 2x plus 1. And then y equals 10 minus x. And we'll just graph them, type them in. I'm having a hard time talking right now, aren't I? 2x plus 1. And then this one's going to be 10 minus x. And I see 2 points of intersection. Now, don't look at these 4 points and say, there's one, there's one, there's one, there's one. No, 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 no. Actually, it's yes, no, yes, no. I need to know where these two functions intersect. They intersect right here at 3, 7 and right here at negative 11, 21. And I'm looking for where they cross each other. I'm not looking for x-intercepts and y-intercepts necessarily. I'm looking for where these two functions meet one another. And that happens at, you can't see where I'm writing, but I'll tell you in a minute, x equals negative 11 and x equals positive 3. I'm just looking at the x coordinate here and the x coordinate here. Just those right there.